Great. Thank you so much. We are excited for our next session. This session is titled Next Generation Tokenization for an Ever-Changing World. And to present this session, I'd like to invite Henning Horst from Comforte. Henning Horst leads Comforte's global research and development team and serves as CTO. Building upon the success of Comforte's existing product portfolio, Henning drives strategic initiatives for new and innovative security solutions with a particular focus to data-centric security. With his extensive technical background and security knowledge, Henning has been closely involved in the strategic product development activities since joining Comforte in 2007. Welcome to the stage, Henning Horst.
Hi everyone, my name is Henning Horst. I'm the CTO of Comforte, and today I would like to talk to you about next generation tokenization for an ever-changing world. A couple of words to myself before we get started. So I'm serving as a CTO for Comforte and taking care of all things technology, and also have been involved in various efforts around data-centric security, including also being one of the co-editors of the NCX9 tokenization standard that came out a couple of years ago. And in the last couple of months, I've been in regular contact to more than 20 of the Fortune 500 CISOs, and I would like to share some of the insights, some of the challenges, and also what Comforte can offer to help tackling the problem of securing data enterprise-wide. So if we look at traditional security measures, and that's also something that many of the companies already have, it's basically a piecemeal today. So you've got your data at rest encryption, column level encryption, transport level, application rules and firewalls, and of course then like people related stuff and endpoint related stuff like DLP, for instance. And typically every company has that nowadays, but the challenge with this is really not an end-to-end protection, and it's more like islands of protection. And if you look at the overall stack in its total, essentially it's a continuous process of protecting, like encrypting, decrypting, re-encrypting for the next layer, and essentially between all these kind of protecting, deprotecting, and re-encrypting, there are security gaps that are created in between those layers, which are regularly exploited. And that's really a challenge for many organizations. And that, of course, gets amplified when you look at the whole transformation that many companies are going through for multi-cloud container microservices and DevSecOps type architectures and environments. If you look at like Docker, Kubernetes, cloud native technologies, I mean, these environments are spun up and down very dynamically on demand, and of course amplify the whole problem of these gaps existing and make it super hard to then apply proper protection to the data when it's flowing through, between these different layers of the stack. And really what is lacking is that end-to-end protection without these gaps. And a lot of companies already have looked at something like tokenization, like data-centric security, to address this problem and to really go for a data-centric security solution. However, what I also gathered in various discussions with these 20+ CISOs I've been talking to, and kind of if you look at the broader environment and kind of companies looking to protect data properly, it's really has been a challenge even with the data-centric security solutions so far. And I mean, if you just look at why is it that still so many companies, essentially the majority of the companies, don't apply data-centric protection, so protection at the data level to the most critical information in the enterprises. Why is it that that's not yet there? That's really kind of a couple of the reasons and key reasons listed here, which is essentially that all these first generation end-to-end security solutions were just too complex. And the corresponding projects took a long time to actually get going, and thus also got to a limited adoption. There was complex infrastructure to manage, so that was really an impediment for the proper adoption. In addition, those first generation data-centric security solutions also required significant efforts to actually integrate the protection. Like, it's one side of providing the protection, but one of the key challenges enterprises face is actually how to now utilize the protection and integrate that into the enterprise environment. And these first generation end-to-end security solutions really were too complex, required significant API integrations per application or data process, included complicated encryption key management processes. So every a second person I talk with in these enterprises talks about these key management nightmares that they had. And essentially the whole security solution becomes invasive to the environment, and invasive requirements are posed to, for instance, changes to data models. And last but not least, if you look at these first generation data centric security solutions, they really come from that era of monolithic solutions and really are incompatible with the modern demands for agility and quick changes like you have in a cloud native environment, or in general in just an agile environment, and are misaligned with kind of this cloud and cloud native first enterprise strategies. So what we created at Comforte is a next generation data security platform, which really tackles all these challenges and provides the end-to-end next-gen tokenization. And so the Comforte data security platform covers everything from actually discovering the data, both in the places you know, but also, even more importantly, the places you don't know, and classifies the data, including creating lineage of the data. So which user, which entity, which endpoint actually triggered what access to the data, what linkage from the data, from its creation to its flowing through the enterprise to accessing of the data. And then from there, of course, it's possible to create policies with our data security platform that define what data needs to be protected and how the data needs to be protected. Over to actually then the whole point of protecting the sensitive data, and we primarily focus around structured and semi-structured data to protect up to then ultimately deployment and operation of the solution. And essentially with Comforte's data security platform, we render sensitive data useless with tokens if and when breached. So let's look at how do we actually do this. So one of the key concepts that we utilize is instrumenting data security as opposed to coding it. And that's one of the key paradigms that in the past, like the requirement for coding data protection, has made all and created all these challenges. And we, in contrast to that, rather instrument the data protection. And I'll cover that a little later in this presentation, how exactly. But if we look at kind of the outcomes of that, essentially, if we look at the data in the clear on the left, let's say a couple of fields like name, social security number, emails, passport number, date of birth, for instance, essentially that data in the clear, we want to properly protect, so that when it ends up in the database or the data lakes that you have in your organization, they are properly protected. And how we do this is essentially using tokenization and we intercept and secure the live data, the sensitive data on the fly in the applications, and protect it utilizing advanced field level data security, dynamic tokenization, so that actually what ends up in the database or data lake is the tokenized data. And one of the unique properties with tokenization, and we do this tokenization according to the NCX9 tokenization standard, where actually Comforte's algorithm is one of the reference standards as well. So we do this in a way that the original properties of the data that's being protected is preserved. So for instance, you see here on the right, when you look at the protected data, for instance, the length of the data fields is actually preserved. And also, and that's a configurable thing, you can preserve really the alphabet. So which digits, which characters are being used for protection of the data. That's something that you can specify in our solution, and essentially then, for instance, result in a protected social security number that also, as the original one, contains the digits. Or alternatively, it's also possible, and there are some reasons why and benefits for that, to actually then say, okay, I want to have the social security number or whatever data field you want to protect look different in its tokenized version as opposed to its live data version. And so, yeah, that's one of the key properties with tokenization. So keeping the length intact, keeping the data formats intact. And also another thing with this tokenization operation is that the referential integrity is being preserved. So what does that mean? Essentially, you can still do your analytics, you can do your joins in your databases on the tokenized data, because a particular sensitive data element tokenizes always to the same token in your environment, that is, based on your tokenization secrets that are specific to you. But essentially, that way, you can do actually analytics on the tokenized data without the need to detokenize that, or allow, as in this example, developers, for instance, to do tests on the protected data before anything is going to production, and without exposing the sensitive data to the developers who actually don't need to see the sensitive data. So of course, then at some point, some applications for their business purposes need to see, and some users for their business purposes need to see and have access to the sensitive data. That's, of course, also possible with that solution by providing granular control by role. So we provide role-based access control in different mechanisms, so that you can really very granularly give access to the people and the applications that need to know the underlying sensitive data. So for instance, say, okay, well, DBAs, for instance, don't need any access, or maybe minimal access, like in this example here, maybe just need access to the name for doing their business, as opposed to then people like a fraud analyst, especially like second level fraud analyst, seeing more of the data really when it comes to, okay, there's some potential fraud being identified based on the tokenized data. So let's say different activities linked to the same social security number token, then you can get back and say, okay, well, let's really look into this, what this was about, and have someone look at this in more detail, and then give that person, for their business purpose, the corresponding access to access the data. And of course, there's a complete audit going along with this, so that you can always see who accessed the data, when, and what they did with it. So let's look at what's unique about this solution. And there's essentially three key things with the solution that are unique. First of all, it's a next generation data security platform, and I'll touch on that in a minute, what that means. Second of all, the ease of integration. So as I alluded to a bit earlier, I mean, it's one thing to have that super secure protection, but in other solutions, typically it's very hard to integrate those into your existing environment. And that's what our solution really puts a focus on, and we put a lot of effort on making it easy for you to actually utilize the data protection. And similarly, in that same vein, also kind of then continuously make it easy to deploy the solution originally, kind of initially, but then also in subsequent deployments and operate it going forward in an easy way. So let's look at the next generation data security platform. So essentially, Comforte's data security platform, SecurityPS, protects the data elements from the capture, keeps them protected end to end, and thus reducing the risk. And we do this utilizing stateless formal preserving tokenization, also FPE, we also support, but essentially without all these key management nightmares that many of you have been experiencing, and also I alluded to earlier, kind of this one of the key things coming up with various discussions with the CISOs I had, like that being a key pain point that we remove with this platform. And last but not least, also providing this in a way that is nevertheless secure, utilizing centralized and isolated secrets for the secure tokenization operation. And it's really another point of where you have to look at into the details of, okay, well, how is the stuff actually done in the different solutions? And just to give you a closer idea, this whole topic of isolation really is important if you look at this overall security of the system. And you can compare it against essentially having some guarding a front door of a building versus you just hand out keys to the building to everyone. And we use that central front door approach where we never hand out the secret to anyone. So you don't need to have key management around this, or key rotation, or tokenization secret rotation in that case. And really only the tokenized data is distributed and not the secrets. And that's very much different, and in contrast to some other solutions around where essentially the secrets, even if it's called tokenization, are handed out to the actual endpoints that needing to do the protection operations, which essentially gets back to kind of classic encryption technologies, where thus key management and key rotation is also required. And it's obvious that the more parties have access to the key, like on the right side here, the higher the effort and the higher the risk is in order or associated with that environment, and the effort associated with protecting that environment. So we really put a lot of effort in kind of continuously innovating in that space as well, kind of from the isolation layer, but also from the core processing piece, being this tokenization or FP algorithms that we use. So we cooperate with top cryptologists on tokenization and FP in that space. And yeah, just recently, you can see here on the right, released what, to the best of my knowledge, is the first quantum-resistant tokenization FP algorithm. We call it FAST. And that's a cooperation between two top cryptologists, Betel Durak and Serge Wardenay. Here, Betel with Microsoft Research, Serge with the EPFL University in Lausanne in Switzerland. And they are two of the leading cryptologists in that space, and also especially kind of focused around formal preserving encryption, tokenization. And Betel Durak was also one of these breaking the NIST tokenization / FPE, FF1, FF3 type algorithms. So second of all, if we look to what's unique about that solution, is the ease of integration. So let's look into that. So with this ease of integration, essentially applications can utilize the data protection without actually having to change any source code. And we also support this even for advanced data structures. And I'll give you an example in a minute. And we provide a true streaming native interface, so not just like one-time or classic like bulk batch type interface, but really a streaming native interface so that you can get the optimal performance for your Kafka, for your Flink, for any event-driven environments that you might have. And that all done without kind of these agents I talked to a bit earlier, handing out the keys to everyone essentially, nor we don't need to have complex APIs or HSMs required to run it securely. And essentially, from our experience with our clients, that results in roundabout kind of order of magnitude 10 times faster to deploy and change versus these first generation data security platforms. So let's give you an example on these advanced data structures. So one of the recent examples that we had where we had working with a client that had free text fields essentially in their database where people were putting just comments into there. And they moved away from another kind of first generation data-centric security solution to our solution. And essentially, the challenge was, okay, well, we have these comments field and people, even though we train them not to, put in a lot of sensitive data, like here on the left, kind of the policy numbers, date of birth, their SSN, and kind of the credit card information or driver's license here. And the challenge was, okay, now we really don't want to protect the whole field, but we want to protect only the sensitive data elements because we want to do analytics and our AI pipelines need to be run on the sentiment that's being put in, like, for instance, looking for keywords like angry. So sentiment around to figure out how the customer is feeling and determine what to propose as a next step, show as for ads, etc. So with our solution, we actually support this capability of identifying the sensitive data as part of like a free text field here, and then based on the context that's around, determine, okay, is this really a sensitive data field that we need to protect, like a date of birth? Or is this something that's just like a date of, for instance, here as an update, which you see on both sides is not protected and shouldn't be protected to not break the functionality. So there's really that semantic capability for tokenizing or not tokenizing. So if we last but not least look at the ease of deployment operations side of things, essentially our solution is provided really following this data security as code paradigm. It's built in a way that's really cloud native. It's not just a kind of monolithic thing from 15 years ago where put some lipstick on a pig, but it's really built cloud native with a deep Kubernetes integration, Helm charts for deploy, etc. How you would expect it from a modern data-centric security solution, so that you can integrate our solution in your DevSecOps and GitOps native life cycles and run it as infrastructure as code without any manual intervention required. And we also kind of build the high availability and resilience by design and by default into the solution. And that's really, if you think about it, this data-centric security protecting the data as it's hard directly at the data level, that becomes a mission critical piece in your environment. And of course, that's where you need to make sure that the high availability and resilience is there. And we built this in by design and by default, so that you don't have to do all the efforts to getting to that. So, and if we look at kind of the results of that, a couple of examples here from our customers, what that meant to them. So if we look at the Fortune 250 financial platform handling more than 300 million customers. So with our approach, both on the integration in a transparent manner, as well as the deployment ease, we got the estimated 32 weeks of deployment down to like a 4 weeks, where it was about, okay, learning, adoption, configuring, adapting the solution, and yeah, optimizing it for the use case. But after 4 weeks, the full application was live and protected. So essentially order of magnitude quicker than what was estimated with another solution. And sometimes, especially if you look at SaaS application, you actually cannot change the application, right? So there's typically commercial off-the-shelf applications you just cannot change. So that's another example where we essentially did the integration within 2 weeks, whereas if you only had like a classic API for data protection, it just wouldn't be possible at all. And similarly, kind of cloud AI, workflows, machine intelligence, again, same thing, transparent integration really made it quick and possible in the first place to do this. So just want to briefly look at the high-level architecture of the solution. And if you look at this on how do we actually do this, you see this excerpts of a table in blue with the sensitive data, and then you have the illustration on the right here with the green being the protected data. So how do we get from plain to protected and vice versa? A typical way would be to utilize one of our transparent integrators, and that transparent integrator would, as I alluded to earlier, allow you to add the data protection to your existing environment without actually having to change your application and without having to code in your application, and would give you that data protection then transparently. We also, of course, provide APIs which provide a lot of smarts when it comes to resilience, high availability, all built in so that you don't have to. And of course, these APIs are internally used by our transparent integrators to do the connections to the actual protection cluster, which you see on the right. So the protection cluster on the right, that's consisting of these protection nodes. These are the actual entities that serve the protection services to the enterprise applications, the EAs, and they are kind of the worker bees that do the protection operations, and they are completely stateless, so running just on compute and memory. The protection nodes are being seeded by the management console, which is the only entity that holds the protection secrets and the policy kind of in a persistent storage. And what happens is when a protection node comes up, it's essentially getting initialized by the management console. The management console hands over the protection secrets and the configuration, and after that, the protection node can operate independently and serve the enterprise applications as part of the protection node cluster. And there's various capabilities built in for self-healing, scalability, etc. So you can really scale this cluster up and down depending on the workload, and especially kind of running this in combination with Kubernetes, you can reap the full benefit of those capabilities. And last but not least, we of course also have a component that's the Audit Console, which provides the insights into what entities, what applications, what users actually accessed, what type of data, when, and there's also alerting capabilities so that you can see if there's anything weird going on, or some for instance, attack in progress where someone attempts to deprotect higher than usual values in your environment. With that, if you like to know more insights what I would recommend is have a look at this guide that I wrote with a colleague of mine. When you look at, okay, what questions should you ask when evaluating a data-centric protection solution? Because while it might seem sometimes very similar on kind of the outside, if you look a bit deeper and know what questions to ask, you will quickly find there are vast differences in how the approaches are in the different solutions. And this way, you can be prepared to find the best solution for your needs. With that, thank you very much for your attention and participating in this presentation. And feel free to reach out to me, h.horst@comforte.com, or via LinkedIn, or just via our typical contacts on our websites.